I would like to introduce Professor Aswin Narayanan. He works as an informatics fellow for University of Queensland and Australian National Imaging Facility. He is nowadays developing and supporting software infrastructure for medical imaging data management and analysis. He is the one of the developers of the well-known software of the Neurodesk project. Welcome.
Hello? Yep. Can you hear me?
Yeah, perfectly.
So, yep. Thank you, everyone. Sorry, I'll just go back to them. So, thank you, everyone. Yep. Thanks for the introduction and this opportunity to speak today. So today I'll just be presenting on the development journey of the Neurodesk platform, how it started, what are the developments over the years, and a lot of the things about how funding came into our project, and also some of the successful grants and fundings we got, some of the unsuccessful things, and maybe some of the challenges we faced, and things like how we, maybe some of the experiences we had and the recommendations we can give from our experience. Neurodesk originally started in 2020. Basically, in our space, we have this issue of having a huge ecosystem of scientific software. These are developed in small teams all over the world, and they have, each one has dedicated purposes, and there's a large variety of tools. And this creates a lot of challenges in terms of how do you run these tools in different computing environments, and how do you port them across to different environments as well. As most of these tools are in Linux, they're not in standard package managers. Some of them require compiling from source, which is can be very challenging. Conflicting dependencies can be a big issue, especially when different tools have the same dependency but different versions of them. You can't install them simultaneously on your host system to set up your pipeline that involves both tool A and tool B. And it also affects reproducibility. Reinstalling tools on different platforms takes a lot of time. And because of the reproducibility challenges, you can have differing results between software versions. And most of these don't even involve the scientific pipeline or the analysis that the researcher is trying to develop. This is just the installation and execution of your software to even start the difficult process that is the analysis pipeline and tools. So this is obviously one of the big challenges we have, and there's a lot of technologies that do help with this. So at UQ, the University of Queensland where I work, there's a couple of groups that developed a few tools that could help with some of these challenges in their own way. But really, this platform came together during OHPM 2020 at the hackathon. One of our colleagues from Swinburne asked a question. So he said, we have virtual desktops running on HPC in one of the universities. And that works nicely for sort of reproducible workflow on the HPC side. So they can go to an HPC and start up this virtual desktop and do analysis there. But how do I take that and run it anywhere else other than on that one system? So that raised a big question, like how do we move our software from one place to another? And our main solution there was containerization. So a team of us got together and started taking some of these things that we had developed individually and bringing them together. A lot of these things involved containerization using Docker and Singularity. One of these applications was called Transparent Singularity, were developed at CAI, where they managed to make Singularity containers appear native instead of, so you don't have to use boilerplate containerization code like Singularity exec to open your container. All the binaries would just be exposed to the host system. So things like that just makes things more seamless and makes containerized software more native appearing. And that way, you get the benefits of containerization without some of the disadvantages. Also, there's the big project called Neurodocker by the Repronym group, and that helps create container recipes for different standard imaging software, especially in the neuroimaging space. And that allows a lot of people to be able to just containerize and run containerized versions of their software instead of using native installations, which runs into the problems we saw on the previous slide. It was also at this time that, luckily for us, GitHub had really pushed out its GitHub Actions platform, which is its continuous integration and development infrastructure. And it was backed by Microsoft. So they had quite a significant amount of computing infrastructure provided to it, especially for the open source communities, because your open source projects can use them for an unlimited amount of time, which was some of the limitations with some of the other continuous integration and development platforms. So it was a good timing. So what we did is we used this to first thing build recipes of all the various neuroimaging and imaging containers we were using at the time, using Neurodocker, and building them using GitHub Actions to auto build these containers, and then making them native via transparent singularity onto a desktop interface, which we built using a Dockerized container. And this is the original version that we built at the time. So basically, this is an LXDE desktop running Ubuntu under the hood, and it has all these containers that it downloads, and then you can run them into this one GUI. And because each container and each version of each container is separate, you can run multiple containers together without them having the conflicting dependency issue. So this was our original prototype. We used this prototype and decided to apply for our first grant, which was the what we call the ADEPT grant, which is the Australian Electrophysiology Data Analytics Platform. So one challenge we'll run into later is that grants often want new ideas. So existing systems, it's a bit hard to promote it in grant form. And what we did is, because we had developed our prototype for neuroimaging, we proposed porting that into the electrophys space. So to support electrophys users, so EEG, MEG, and those kind of areas. So we would want to integrate more EEG, MEG type toolkits into our container library. And this was a funded grant. We had three partners, University of Queensland, Swinburne, University of Technology, and University of Sydney. So the three of us broke into three parts. So UQ focused on the core Neurodesk platform side. We had our Swinburne colleagues focus on the EEG side, which is their specialty, and the USID worked on interoperability, where we wanted to integrate this platform into some data repository technologies, which will actually come up later. So it was our first successful grant. Every time you see a green tick, it means we had a successful one, and if it's a red cross, it means it wasn't successful. So this moved us into the next stage. That grant funded us for just over 2 years, and let us hire one extra team member into each of our teams and things. So over the next 2 years, we had a bigger uptick in the community as we developed the platform further. 600 pulls from Docker Hub of our main container. That's the master that has all the virtual desktop in it. Quite a good set of growing GitHub metrics. And we also we originally had intended this to be mostly an Australian user base, but there were users from Europe and North America that were keen to use the platform. And also we started joining various hackathons like the Brain Hack Global, and started to get community contributions to the container library, because the softwares individually need to have their recipes contributed to our library, because we can't work on every single possible software that people require. So we started to see some growth there. We had applied for what's a KX&T innovation grant. So this was a UQ, University of Queensland grant, but also in partnership with Oracle Cloud. So this was our first foray into the commercial cloud side. Oracle Cloud was really starting to spin up their research support node of their company, and they decided to promote our project via Oracle Cloud credits. And this was really useful because I think it might depend on the software, but as a platform, there is some overheads and infrastructure requirements that we need. We need to be able to build our software, run these development environments, and also the compute helps a lot with the building process, and also some other things that this enabled us to do, we'll talk about further. The grant was focused on adding GPU support, which we managed to do via this major development cycle. So this is basically our second cycle from the prototype, and also more cloud type integration. During these 2 years, we also decided to work on 3 specific technologies. So at the time with our prototype, we had mostly used, other than Docker and Singularity, it was mostly in-house code. The first thing we did is we experimented with porting our virtual desktop onto Jupyter Hub via there was a remote desktop gateway kind of plugin. So we played around with that and we realized that we could port this onto the Jupyter Hub platform. And that really opened up our project to a lot more different systems. Like we were able to use the full Jupyter framework, things like Jupyter Hub extensions, which is extensive. It's one of the biggest projects, obviously. And also, there's a platform called Zero to Jupyter Hub, like a system where you can use Jupyter Hub and spin it into Kubernetes, which is a cloud infrastructure as code type framework. And this meant we were able to deploy Neurodesk via Jupyter Hub on Kubernetes for scalable cloud instances. So now we could just spin up entire workshop type instances in a couple of lines of code and have it ready for users to use and scale them down as well, which is more critical because we don't want to waste our resourcing. So this opened up a huge amount of room for us to work with. The last thing was, interestingly, while we were originally, our prototype used to have you download imaging containers one at a time. So if you wanted to use, say, FSL, you'd have to download the entire 6 gig FSL container. And then if you wanted version 2, you'd have to download that. So there's a lot of network bandwidth and data download type of limitations there. What we did is we experimented with CERN's CVMFS file system technology, which they use extensively for their data and their software deployment. And this was perfect for deploying software because this deduplicates the file system. So that means things that are the same files will just take the same amount of space, which is very common in containers because a lot of containers are of a base image and the base image is the same, might be Neurodebian or Ubuntu, same version. So this heavily streamlines the amount of space that our container library takes on our servers. And also by its technology lets you stream it over the internet. So you only pull and cache files that you use. So let's say we can now provide 100 to 200 gig or even higher container library, which it's a growing library. But when a user actually only accesses that file that they're needing, only that file gets downloaded. So they have access to the full repository, but they only download the files that they're using, which helps a lot. And this was actually inspired by a user we had in Perth, which is quite remote sometimes for network connections in Australia. And they found it difficult to download some of those containers. And by providing CVMFS streaming, they were able to access the data much better. And now we've moved our entire platform to delivering containers by CVMFS by default. Also talking about cloud, 2 infrastructure providers we were able to integrate with. So the first one was Oracle Cloud. We used the Oracle Cloud credits to deploy public and sort of limited authentication access virtual desktops. The public ones are for users to work and they can do testing of public data, try out the platform, which is really helpful because it really helps to promote the platform when you can just go to a browser and access it directly rather than having to download anything at all. And also you can now do quite a bit of data analysis as long as it's not too heavy. And we have one locked behind an authenticated version, which is a bit higher, has a higher infrastructure behind it. So you can actually run bigger analysis. The other one is Nectar, which is the Australian Research Data Commons provided infrastructure for research computing and based on OpenStack. And they integrated our desktop library into their desktop library platform. So now Australian users, any Australian user, a researcher can now access Neurodesk on the Nectar cloud for free to do their analysis. It's a timed, like a 2-week timed image, but which you can keep extending. But now any user has access to that. So this cloud really brought out a lot more user base and accessibility to the service. So that really helped us with building up what we would call maybe our general design that we've sort of stuck with at the moment. This is our production design. So community contributed recipes will go through our automated container building process. And then those containers can be deployed to users in a variety of manner, like via cloud, via local desktop interface, all accessible from the browser. And you can just download individual containers if you want to do just off non-interactive analysis. So that flexibility is there. So the next stage I think was 2023 and 2024, which is it takes us to what we're currently doing. So we got a health research accelerator startup funds to expand our team. So we grew, added two more members. This allowed us to do general improvements. We'd collected a lot of things we wanted to do generally, improve our container building process, the desktop interface itself, all those things. It also let us port the thing into a desktop app, which is actually the Jupyter Hub app, but we've ported it to Neurodesk. So now it's a fully a downloadable application, and it has everything included in it. So it's a more streamlined experience. Also helped improve our cybersecurity, and we added more monitoring to our system so we can get metrics and monitoring of the public cloud instances. Some of the challenges we face there is one issue is public cloud, you don't know, people can use it for a variety of things. We did run into things like people doing crypto mining and things like that. So we had to do monitoring and eviction of those users. So, and actually our later, this funding really helped with that. The person who worked on it has got all the crypto miners off of our system. So it's usable by the research community. We also at this stage started to look at sustainability plans. So so far, most of these things are grant funded, and also our institution and like our research infrastructure organizations support this. But we wanted to see if we can commercialize it a bit more so that we can support the overhead instruction. This is mostly a cost recovery model. It's not, and just to maintain our overheads. So one of the strategies we've gone with is we can provide Neurodesk as a service. This is targeting labs and especially workshops because workshops often need a whole host of instances with data and software that are identical to a whole bunch of users, and they have to be able to use it in a very standardized way so that the instructions in the workshop applies to each user. And we've got Neurodesk working in that manner using our Jupyter Hub and Kubernetes workflows. So now we can spin up a instance for a workshop and get some cost recovery from the workshop organizers and things like that, and supply that as an instance for those users. So it's very good for this workshop model. This is also quite a common strategy for a lot of open source software we have found, which is they release their source code open source, but they'll have a sort of as a service model for users or for specific use cases or commercial clients. It was around this time also we got a Neurodesk a paper published in Nature Methods. A lot of it is talking about reproducibility and how this containerization in Neurodesk can help with reproducibility and the portability aspect. And the paper is online, and I definitely recommend if you're interested to check out the paper, and we're pretty happy with how that's gone. Coming to more maybe this year, so this is maybe what we call a fourth revision. We got OpenGL support via virtualGL to do hardware acceleration, which is really important for a lot of the tools that we use. We now have a portable edition that doesn't use containerization, so it doesn't need any privileges. And this is something I think we really want to focus on going forward, which is to get a version that is that can run on any system basically without any sort of limitations, and that really opens us the platform to be run on very special devices, things that are on lockdown networks, and knowing since it's imaging a lot of, we want to see if we can get into like hospital environments and things like that. Speaking of hospital environments, we have Neurodesk on the scanner via the Siemens Open Recon platform. So you can take Neurodesk and push it as a package into Open Recon and run it from there. And that's something our team's working with Siemens on as well. We've engaged with three basically research cloud providers: Jetstream 2, which is the American one, EGI from Europe, and Nectar from Australia. So these are the three public instances we provide for users thanks to their support. So engaging with these research cloud providers have been really beneficial for us and for them as well, as we want to try and uplift the use of their platforms, because these platforms by default, they provide a typical cloud environment where you have to go and create your own VM and then install your software and then run it there and manage the VM. And like, that's a lot of overheads for a lot of research workflows. So we want to work symbiotically with these providers to make it very easy for researchers to use their research computing hardware and infrastructure but with our software to make the access easier and remove all of the extra steps that is not required to do research. So today, we've just recently got our CZI EOSS Cycle 6 funding grant funded by the Wellcome Trust. We're going to be using this over the next 2 years to enhance our container building system because we want to improve the way users can build containers using our framework. We're also looking at trying to port this to a system called K3S, which is very lightweight Kubernetes. So that way you don't have to use the full heavy Kubernetes infrastructure. You can use lightweight Kubernetes to deploy a fully workshop level instance on K3S. So that'll open us up to more different hardware and computing environments. We also have an example gallery with CI. So I'll just show you that next, actually. So basically, this is using Jupyter Hub's like workflow website publishing mechanism. So you can basically publish a notebook and make it into a website. And we want to make this so that you can publicly engage the community and share open workflows. All the software is already provided by Neurodesk, so you don't have to worry about that. So you just have to use a standardized environment, which is Jupyter Notebooks, and you're able to publish a workflow. And also we want to move towards this model of interactive notebooks and interactive papers. So you can publish a paper with actual workflows running in them and things like that. So we want to move into that space and support that kind of workload. We also we engage with some other communities. So a lot of this is biomedical imaging and EEG areas. That's where most of our containers are based in. But talking to some of our colleagues in the microscopy and bioinformatics space, they were interested in using our platform or integrating with it. We did try for a grant recently, it wasn't successful, but we're looking at other avenues because I think we want to really generalize our system and make it so that we have a core set of operational code that can just deploy into different areas of research instead of being specific to this, because nothing in our platform is actually specific to neuroimaging except the containers themselves. And we just want to open this up to a whole variety of different types of containers and research fields. Another current application we have is to integrate Neurodesk into XNAT, which is a popular biomedical informatics platform. This is via the Australian Imaging Service, which is a project that set up a network of XNAT instances across Australian nodes. And we're trying to do this along with the National Imaging Facility where I work at, and try and integrate Neurodesk as an interactive analysis environment that's integrated into a repository. So this means that if you push your data into this XNAT repository, you can click a button and you'll have a Neurodesk interactive window with your data mounted, and you can do analysis right there without moving your data anywhere. And that's what we're trying to achieve with this project. And this is a current initiative we're looking at trying to get funding secured for this by start of next year. We also recently got an ARCDP grant from Australia. We're going to plan to use this to document and benchmarking of pipelines, to set up standards for reproducible benchmarked analysis pipelines, develop standardized methods for describing analysis from raw data to outputs, and also implementing these and integrating these standards with Neurodesk website.org and brainlife.io for distributing this to the community. So in summary, at the moment, this is our current uptake. So we've got almost 1,200 monthly users based on our website traffic from over 60 countries, like 19,000 downloads from our main repo. And we're using it in 3 different university courses for more than 100 students across UQ, Wollongong, and University of Southern Carolina. And also a whole bunch of workshop instances for multiple users, because it is something we can spin up and spin down. So it's been quite useful in the workshop space. So just a general summary of our grant funding that we've got so far. Successful, we've had the ARDC Platforms Grant, which is the ADEPT project that initiated it. We got the recent CZI EOSS 6 funding that's going to cover us for another two years. The UQ-KXT grant, which is the UQ side, but we also got in conjunction with the Oracle Cloud Credits, which supported a lot of our overheads for a long time. We got a UQ HERA from the Queensland Digital Health Centre, the Health Accelerator one that helped with a lot of the hiring more people to do general improvements in the desktop platform and things. And finally, the DP grant that's just been received. We did apply for a LEAF grant to do the extending Neurodesk into other areas, which wasn't successful, but we're looking at other avenues now. And twice, I think we applied for this Canadian award and was not working, and also the Queensland Eye Awards this year, where I think a lot of the competitors were AI related, so it was a bit hard to compete in. So a summary of our sustainability model that we're trying to get. So we want to be as community oriented as possible, and we want to tool our system so that community can contribute as easily as possible as well. And we've managed to get CVMFS servers hosted via the Open Science Grid and EGI. So that really reduces our overheads because research infrastructure, international research infrastructure is supporting their own communities with that thing. So we just need to provide the software that actually runs on it, which is a lot easier for us as a unit. We are trying to push Neurodesk as a service for in conjunction with QCIF, which is the Queensland Cyber Infrastructure Foundation, and also with help from UQ and AWS to run Neurodesk as a software service for workshops and things. We've had support from the Australian Nectar Cloud from the very start of our project to run instances and support the building and the public infrastructure, public services. AWS is our most recent cloud provider, as well as Google Cloud from the last 2 years. EGI, which is the European cloud provider, has been supporting us, as well as Jetstream. And we've expanded our Oracle partnership, but it was really useful in our development and progress. Yeah, so I think some of the summary from this actually. So we found in our experience, so grants, one of the challenges with grants is they usually support new ideas. So whenever we submit a new grant, it needs to be framed as a new idea. It's hard to submit something existing, but also say, and just improving features in it, which is ends up being a lot of the work. So what we often do is we try to develop out one idea first via one grant funding or something like that, and into production. And when we have a new idea, we try to just prototype that so we can demo it, but then we'll try and apply for a grant to fund it into production. So it's better often to focus on one thing that works really well and keep other ideas. And it's always good to try new ideas, because most of the things that were successful were actually things that we just tried on a whim, actually. Things like the Jupyter Hub and CVMFS infrastructure were just things that we tried on the side, just thinking, would this be interesting? And they turn out to be core parts of our infrastructure and system. Maintaining and operating this a platform and the operational code base behind it is difficult to find funding for, because most things want to fund ideas and new code. So this is where you have to talk to your institutions and infrastructure support channels. Like, for instance, I'm funded by University of Queensland and the National Imaging Facility, and some of my colleagues are from the University of Queensland. So we really need to show them the value that your system has for the university and the providers to allow them to support the maintenance of this, which is pretty critical. Obviously, sustainable and open source is always a challenge, because we are basically giving software away for free, but we need income to support it. So a lot of platforms have gone with a software as a service model, and we're trying that at the moment as well. And it is challenging, but I think that's one of the better options we have. Cloud providers have been a huge help in terms of supporting the system. So always try and engage research cloud providers and commercial cloud providers and see if you can make a mutually beneficial setup between them. One thing is with our project, which is something we're still learning, is funders and providers want metrics, and this can be challenging with open source, because when you're giving software away, it's hard to get metrics for how much they're being used. So when you're setting up the system or developing a platform, just think about metrics, like how you can keep them, how you can get them, and start shoring up metrics when you using building your system as well. And it's also useful for your own development, because you might want to know which parts of your software being used or not as applicable, so you can be focused. And very importantly, I think having a website is amazing. It's really helpful promoting your application. We set up a website very early on, and it was pretty it was pretty rudimentary at the time, and it's developed into something I think we're pretty proud of. Just having a full-fledged website with all information, and even if it's always good to have one. It really helps with promoting, and it can always send people to a website and makes it a lot. It really rounds the circle on trying to get new users in. There's more information on Neurodesk actually at the Thursday session. So on the open science session, my colleague Stefan Bowman, he'll be talking about general how to use Neurodesk, I think, and the general architecture behind it. So if you're interested in the platform, I'd highly recommend joining that session. And also in the tools of the trade session on Thursday, my other team member, Tui Dao, she's going to talk about BIDs, data standardization using BIDs, but in the Neurodesk context. So I just highly recommend both of those talks if you're interested in the platform. And we'd like to thank all these funders and the community contributions to our project. And it's been really beneficial in supporting us through the years. And thank you, everyone. And if you'd like to join us, just this is the information. And thank you.